Hi, everyone. My name is Mohan Reddy. I'm co-founder, CTO of SkyHive. And today, I am going to talk about ethical AI. And the objectives of today's webinar are: one, I'll give you why ethical AI, what is the overview for it. Two, we'll look at the landscape, how regulations are being imposed. Three, SkyHive's approach to the ethical AI and what we do in order to reduce the bias. And then last, we'll conclude, but please feel free to make it as interactive and ask questions if you want. Okay, with that, let me go. So when you see the world right now, it's not perfect. And many systems that are designed not for real usability, right? What you see here is like an uncomfortable design, a chain fork or a wine glass that is not usable. I mean, you could still do it, but it's not usable by the people, for people, in the true sense, right? And there's so many hostile architectures out there. People put boards so that they could discourage people from sitting and sleeping. This is all some sort of unconscious bias. The systems is introduced so that things are not democratized enough, right? And you see this quite often, in the systems that are being built, because it's not usable for or built for everyone. Right? So you really need to build technology that works for everyone. That's one of the fundamental ethos of SkyHive is we want to build something that works for everyone, right? And we want to contribute towards it so that we have a technology that just works for everyone in this planet. Because at SkyHive, our mission, vision, purpose is to reskill and upskill this planet. We want to reach 8 billion people through our technology. And I say 8 billion, we do not want to exclude anyone. And so you have to build a technology that works for everyone. Right? So before I go in there, let me start off with a small story. Right? This is about in Germany, right? There was this gentleman by name Austin. He had this horse called Clever, and this horse was known as Clever Hans. And this gentleman trained his horse to count, right, or identify colors and do arithmetic functions. But horses can't talk. But what it did was, when you say 1 + 1 = 2, the horse would tap twice. Or when it saw some color, say, is it blue? Is it red? Is it orange? When it saw the color, it would tap. Right? And in any other arithmetic functions, they would, when it comes to the answer, it would tap. And it was really people really thought this is really a clever horse. It just knows everything, and went around the whole Europe and tried to garner a lot of popularity on it. But it turned out that it wasn't really intelligent. What it was is it was really looking at the horse's owners' facial cues. So when you say 1 + 1 and it is trying to tap 1 and 2, there is a very kind of expression that the owner had, and the horse would catch that. It says, okay, that's the answer. So in effect, the causation and the correlation is very different because of it was not so much on the counting, but it is on the owner's facial expression. So if people wanted to really debunk this myth, they took the owner far away, and they started testing the horse again. Okay, now let's try to count. And it was almost all the time giving out false results. And the reason for this is the horse was actually trained on a different objective function, and that objective function was to look at the owner's facial expressions, and that was the cue for it. Right? So this is what we call as the Clever Hans phenomenon, right? In statistics, there's spurious correlations that occur, where it's the experimental's body language, but it's not the cause of the answer. Right? It's not the correct calculation was based on somebody's body language. And this is exactly what happens in the machine learning as well. There could be conscious or there could be unconscious bias, and we really don't, sometimes it's not intentional, right? There are certain spurious correlations that will work against people, especially when it comes to the HR in terms of the recruitment or in terms of recommending certain people certain jobs. So I'm going to talk about all of these in my subsequent slides, but this is wanted to show how these spurious correlations in the data can cause unintended consequences, right? Which is why we really need for our AI systems to be ethical and explainable. Right? We want to verify the system. We need to explain to justify, right? An ability to explain the decision. And we need an ability to control because you want to be compliant with the legislation. And you want to learn from the system because the systems are trained in millions of examples and how to access those patterns that humans don't. So you need to have an explain to discover. Then there's the explain to improve, right? The improvement of the system, understand the weaknesses and all of the associated biases. So these three, explain to justify, explain to control, explain to discover, and explain to improve. These four important aspects that we will study throughout this webinar in different shapes and forms. So up until AI systems have been proliferated, the world is very deterministic. It's Turing complete, fully engineered system. There are specs associated with it, and people build the systems as per the specs. They test it, and it works. It's very deterministic in nature. But in the new world, everything is trained, right? You're moving away from the things that are programmed and you're trained. So you're training a system based on the data. So a model is built based on the features that you extract from the data that it is trained. And it is perturbed sufficiently so that we know it behaves within those constraints. But tomorrow, if the model encounters the data that it hasn't, we cannot predict the behavior. It could be completely different. So there's always this variability on the type of data it is encountering and the type of decisions it would do. And this poses a whole new set of challenges. Right? But it makes your systems very powerful because now you can do infinite combinations where in the old school engineering, you would have to codify all of that, and which is impossible. Right? Now you have a whole different way of understanding and learning the system. But there is this whole variability of the data that is associated with it. And if the data is bad, the decisions will be bad, the garbage in, garbage out, or bad data and bad outcomes. And this is a challenge, right? And this opens up a whole new Pandora boxes, which is why, you would have to really, put a lot of guardrails around the systems that we interact with, right? So what do we do at SkyHive? Right? So, we walk the talk on the responsible AI. And, our goal is to be the leader in responsible AI, right? And we've invested in looking at all the existing legislations and all the best practices, in the responsible AI. But, in the current landscape, when you look at security, when you look at privacy, there are NIST standards, there's GDPR or CPRA or all other privacy guidelines. But for AI guidelines, they're still pending. There's no an act out there. There is a draft EU act, and there are others. So what we have done is we proactively went ahead and created our own responsible AI framework, which we call as Midas Plus. And through Midas Plus, we support or we worked with external experts and developed operational practices for for the US, the Algorithmic Accountability Act or the NIST standards. And the NIST has many things coming up in terms of the 4 principles of AI or the concept papers. Then FTC has their own guidance. And more recently, New York City has passed an ordinance, anybody who is in the recruitment business using AI should have done external audit. It was supposed to go in effect on January 1st, but because of the complexity involved, they moved it to April 1st now. But there still is in the realm of possibility of how we will be now subjected to AI audits, right? And there's this Canadian Act. There's so many international acts that are coming up, but these are not really very well established as what we would see with respect to the privacy or any of the security aspects out there. So we are constantly looking at all of these acts and how do you comply to these controls, comply to these policies. And so we've also partnered with the Responsible AI Institute, the members, and we're part of the HR working group, really helping and being in the forefront of how we can start building systems that comply to these standards or these standards that are coming. Right now, many times people might say, building out all these standards or with this AI, this might just impede innovation. These standards probably will, how do I give my models to someone to audit? Can they reverse engineer? Could they do it? These kind of things really impede in building responsible systems. But I do want to tell people, we've been living with this. Cars are brakes. The reason why they're brakes, because then you can go fast, right? And it's the same thing. You got to have systems that are that help you stay in the lane and be responsible, so that now you can take the immense power of these AI systems out there. And that's why there is a responsible way of looking at ethical AI and ethical AI practices, as opposed to just going all this would impede the innovation and stuff like that. Right? So I I talked about just building out the story as to why there will be ethical underpinnings of the new intelligence system. Talked a little bit about the landscape. Now I'm going to get into how SkyHive is looking through this. Right? So here's our AI guiding principles. Right? Socially beneficial. We want to avoid any unfair bias, test for safety, be accountable, and incorporate ethical and privacy design principles and uphold higher standards of scientific excellence. So this is our core. This is what guides all the systems and the models that we develop, building out the operating system for take the world into from job-based to skill-based. Right? And so it's built into our a whole new thing, we call it as ethical AI ops, right? By design, starting from training the models as to how you will be looking at various features, and building out bias-aware algorithm, taking out the bias from the data, then validating it, right? So various types of validations, including human in the loop checks, and checks for explicit validation, then deploy these models. And remember, I talked about Midas certification, right? So through those governance controls, we'll be checking against those governance controls, making sure that the models have gone through all those checklists. then you infer, and within the inference there's APIs, and you keep monitoring because you got to make sure that there's drift analysis. They are continuously monitoring for the fairness. When you look at if a model is drifting away, there's certain changes to our fairness scores, then you have to go through the whole cycle again and take the model out, retrain it, and make it fair enough so that now you have this whole virtuous cycle of making sure that the models are 100% fair, and there is continuous monitoring of it. And our goal is, if you go back when I said there's data and the models are getting trained, by now incorporating ethical AI ops, we are making it real time. That is, every time there's a model, every time there is new data, looking at the drift, monitoring it continuously makes it ethical in real time, as opposed to all the audits that happen, the security audits or the pen test, or all of these at a point in time, whereas here it's real time, it is a continuous operation, right? Okay, so how do we remember I talked about the very first thing is we look at ethical feature engineering, right? We want to look at the bias. So what are the different types of bias we look at? There's sample data bias, there's algorithmic bias, there's prejudice, measurement, and exclusion. So let me talk about the data bias. In the data bias is the very first thing is the bias starts from the data. When you're looking at the data, there could be all kinds of correlations. If you look at genders, within it, there could be chairman or chairman. So there's more towards the masculinity. In the model, they're not human. The models don't have common sense. They just look at the language constructs and pick it up, and more data towards that, it will bias your system towards men quite a bit. Right? And we have seen this, right? In the job descriptions where most of the data scientists had a subliminal bias towards men. And nurse, and the job description for nurses were towards women, right? Or all the jobs in the beauty field were actually surprisingly gender neutral. But it's just because when people write these job descriptions, or when you pick up the data to train these job descriptions, you would see that kind of bias. And this is usually what we call the data bias. Then there's algorithmic bias, right? And it is primarily what kind of algorithm you're using, how is it, right? You have to be very careful. And this is usually when we are training, if certain algorithm works very much towards correlated data, then there are chances of it being biased, right? So you have to choose the right algorithm and the right kind of features that go into the algorithm. Then there's prejudice, right? In general, there's always most of the times when we build out these algorithms, they're supervised. When it is supervised, you create certain labels. And who creates the labels? Humans. And there's a prejudice, right, when they create these labels. And so these hand-coded labels sometimes can skew to how to the human bias, to the human prejudice. And obviously those permeate into the model training and the model outcome as such. Similarly, measurement bias, right? So how do you measure? How do you quantify? What types of measures? And so these could also include the bias. For us, exclusion bias is very important. I'll give you an example. In multilingual scenarios, right? We use entity recognition to understand various skills or to understand different job titles. Now, what you've done is you've taken, say, like all the entities in English, and because you had trained on English models, so you looked at all these entities. Now you go to another language, and you haven't trained enough. You've excluded certain entities in that language. So what happens is now the model has not learned certain types of entities in that language. Now you go to a country where people have English resumes and that pertinent language resumes. Suddenly, you will show more jobs, you'll see more recommendations for people with English resumes and not with the local language. Why? Because they got excluded. This is the exclusion bias that happens. So, you do have to make sure that, there is balanced data set. There are balanced features, within the data that we are seeing. And so exclusion bias is one very big thing. So, we see a lot of these biases in job descriptions, right? Like high use of gendered words, superlatives, right? And use of superlatives usually tends towards masculinity, and demanding requirements, like you're supposed to work long hours, you have to do this. This will exclude certain types. This will exclude parents with kids, or this will exclude moms. This will exclude women, as the study's shown, right? And more gendered pronouns or more keywords using it. So if you don't take care of these, we the models tend to learn all this bad behavior and it memorizes all of this bad stuff, and so you'll see demanding requirements showing more towards men, or towards those demographics, if you will. And sometimes undersampling or oversampling, it leads to some undesired correlations, right? So the data will exhibit stereotypical biases. So you have to be super careful. You're not oversampling or you're not undersampling the data, and so you have to make sure that everything is balanced. This is a very tough thing, in terms of it takes many iterations to get your data set right, to get your features right, and that's why it is very important to have this by design as opposed to an afterthought. So right when I'm trying to build a model, and you have to incorporate all these practices going forward. Am I just doing run-of-the-mill feature engineering, or am I going to make sure that my features are very well represented? Is my data undersampled? My data is oversampled? You can do lots of correlation analysis. So, in the machine learning cycle, we spend quite a bit of time just preparing the data, right? Making sure that we have the right amount of data and the right distribution of the data. Many people don't, right? In the whole goal is I get the data, I'm just going to go and start building the model, and then I have the output, and here are my output metrics because I have a golden data set that probably is not representative of all of it. And says, yeah, this is all great. But then when it goes in real world, you will see all kinds of spurious correlations that has happened. This is because you haven't paid enough attention, in the beginning, building out this data set and with the right distribution. And I have two questions in the chat. Can you define ethical, right? Do the right thing. I mean, being fair and doing the right thing and making sure the model is fair under most of the conditions is what is ethical. Um, in the, like, in how, what is used to interpret ethical AI, it is based on a model of medical ethics. And like, interpretation of ethical AI is, it's manifold. Manifold in the sense, like, how do you, the first thing is trust. Like, why did I get a result what I got? What was the reason? So most of the machine learning systems are black boxes, right? Like, I've given an input, I got the output. And that'll never, they're not trustworthy. You really don't know, and people have hard time. And very specifically, like, you have to be very careful, in those systems that are mission critical, that are like, when life and death's involved. So you have to make sure that, like, there are enough guardrails and make this as a glass box. That is, I know what's happening. I know underlying, like, here are all the features that have been used. And like, this is the outcome of it. Now, to the end user, you have to make sure that you apply the ethical design principles. That is, why am I recommending this to you? What was the reason for it? And, like, and what is the confidence in this kind of recommendation? So that it's almost like, the warning, right? To giving them, like, use it and look at it, like, with caution, because, like, the system's not 100% confident in the answer it assures you. And this level of transparency is very, very important for the ethical, and all of this is, very important for the ethical layer. Cool. So I'll move on to the next set of slides, right? So there are 4 categories that we look at, right? Data, like, the DSRU, denigration, stereotyping, like recognition, and, like, any underrepresentation. Like, are there, like, in you seek out explicitly for these categories. And in SkyHive, what we do, we go and bring in data from over 200 countries in the world, and all of the labor market data, right? Versus, people's resumes, CV, job boards. There's some jobs, compensation data, data about the companies, some census data, future-facing materials like patents. You bring all that in. It's very unstructured. There's nothing like, it's pure natural language text. And, like, there could be many things out there. Like, like, we are looking for the best lawyer. We are looking for, you know, a kick-ass doctor, whatever. Like, there could be any kind of, like, denigrations or kind of words and superlatives people would use. And, like, you do want to watch out for that, right? What is happening within that. And so we perform some kind of sentiment analysis on this one. Like, what is this piece of text that I am looking at? What is the sentiment? What are the keywords that are looking for this denigration? So you look at that. And a lot of stereotyping, because the world is full of that, because, all of our biases creep into it, and there's so much of stereotypical stuff that you would see, like, in the data as well. And obviously, like, when you pick it up, the machines would learn the same. And you have to do some sort of recognition, right? Like, am I, like, recognizing the right facts? Like, am I looking at, certain domain level constructs? Like, am I building on top of that? So that's and then underrepresentation, right? And I really talked about a little bit earlier, but underrepresentation of, like, if there is underrepresentation of certain groups, certain minorities, certain objects. You look at the distribution in the data, and then you have to think about, how do I mitigate that? Like, for example, here are certain examples, right? Machine translation. You translate, he's a nurse, she's a doctor, to Hungarian and back to English. It will result in she's a nurse, he's a doctor, and just changed completely. So when you shift and change the languages, the whole meaning is changed completely. So whatever the results that you're seeing in one language are flipped in completely different language. So, you have to make sure that, you're accommodating for this, right? And then I talked about sentiment analysis, right? It ranks sentences containing, female noun to be indicative of anger. And these are all, by the way, studies done, like extensive studies done, and there are many papers and literature around there. And I'm only showing like very few examples out here. Right? More often, than sentences containing male noun phrases. And so this is a big problem, as you could see, right? And the language model right now, as you can see, the world is evolved. We have seen large language models. The big rave about the GPT chat out there, right? Which is a big language model. And so obviously when you're training at using this large corpora, it's he's a doctor has a high conditional likelihood, then she is not. It's just because it just trained on the data that is there. And so when you're asking the chat, some levels of what should a doctor do, and sometimes it can correlate it to mail and then give you the results around it. Or when you have all the data and you're looking for a jobs or matching the jobs, most likely the men would be matched if the skills are all equivalent to the doctors. And this is a huge problem with the language models right now, and we're seeing this quite a bit. And the same thing, word embeddings, right? Everything uses embeddings now. Right? The man, woman, to computer programmer or homemaker, these are automatically generated, and these biased embeddings are trained. One thing I want to tell, right, and this is very, very important, is the machine learns, and it's very hard for the machines to unlearn. And because these are large language models, you don't train from the scratch. You take these and you keep fine-tuning. You keep fine-tuning to them. So when you're fine-tuning it, the underlying layers of these systems have learned something. And just like humans, when you see something, it's hard for you to unsee it. It's hard for these machine learning models to unlearn. This is a classical problem in the machine learning. You check the model out, you rebuild the new features, and you build the whole model all over again. Yeah, the possibility is now you erase the memory and you recreate it. But it is an extremely expensive process. People can't afford to do that. So even there were all these correlations that got attached to it, the machine learning models have a hard time unlearning it. And this is an open problem. And this poses a lot of problems in the ethical AI literature as well, because you can show that, hey, I've seen bad data. I've seen some bias into it. I took it out and I trained it. Now it looks fine. But a few days goes by and suddenly you will see the behavior coming back again. Oh, wait a minute, I changed it. What happened? No, it learned, but it has never unlearned. This is a problem. And you will see this quite often, and this will be a huge challenge. Do we have an answer for it? I don't know. We don't, right? And so that's why it's a continuous research problem as well. You have to be the forefront of looking at it. So at SkyHive, we employ different bias mitigation methods. Right? What happens is one of the ways we do is, you take the approach of negating. So you litter your code, the data, with all kinds of bias, put everything gendered males, years of experience, positive relationship years to salaries, positive relationships to the degrees, to certain bias, and then go train it, right? Looking at this model, we using this. Then what we do is we apply negation to it. That is, after that, you now know that these are the effects of these bias features, and you subtract them from the model. So which makes it cleaner. And this is a negative effect, right? In the sense of you go and subtract whatever that is out there, and you've trained the model to understand what is bad, and you've trained the model to know that you have to ignore that bad completely, so that you're bias free. Just like how humans are, you tell them what are the consequences of it, and you should not do it. If you do it, what happens? It's a similar process. And so we apply many techniques in order to remove those effects from the actual outcomes. The second approach we do is counterfactual data remedies. That is, if you see the data that may say a man who's proficient in surgery, then we generate a counterfactual sentence by substituting that gender, saying the woman is proficient in the surgery. So you have taken the data and you created a counterfactual of that, and now you created a balanced data set, so that these swapping and these gender terms, where you're trying to de-bias these word embeddings or pre-trained language models or any co-reference resolutions within it. This is you have to do it over and over again. It really requires to create a curated list of words to substitute. And remember, I talked about the whole Hungarian translation back to front, and you have to do it for all the languages. You just can't do it for English alone. In a situation where where SkyHive is multilingual, we offer our services in many different languages end to end. So these natural language systems have to be trained into any different languages. So this swapping has to be done in different languages. Again, it's very hard because other languages have adjectives, articles of pronouns that you have to adjust many things to comply with the gender. It's not just substituting a word alone in certain languages. And it's just why it takes over you and the nuances in other languages as well. We also look at other augmentation techniques, right? So look at data augmentation. How do you I'm building a model in English and I'm building a model in Arabic. Not much data in Arabic. So what do I do? So there's different ways of how you have to augment the Arabic data. Or certain domains you have a lot of data, certain domains you don't. And so you use a lot of generative techniques, look at subject matter experts, looking at other kinds of data, you bring that in and you augment it so that the models are trained on a good representation. gender tagging, right? Like, I talked about, like, the gender tagging or any bias fine tuning. You have to go do hard debiasing, like, sometimes, like, pick things up randomly and do human in the loop tests for the same as well. Not like, learning neutral embedding, but, the word embeddings, make them as neutral as possible within that. Predictions are something very, well, these are the ones that can cause a lot of harm. How do you constrain it? Like, so you have to put very hard, high thresholds. And when only when it passes those thresholds, that is when you can show these predictions, otherwise you don't. And then, like, any adversarial discriminators that we see, you constantly adjust it. So this is always a moving target. Every like, every day when you retrain the model, every time you're building the features, everything that would be, you have to go and do this over and over again. And that's why, like, building machine learning systems a lot of times it's like a meta problem. You need AI for AI. Because if you're dealing with this at a scale that SkyHive deals with, in terms of, like, ingesting 20 terabytes of data on a daily basis and working on over a petabyte of data, this is hard. You cannot do this by human. So we apply, many automated techniques, like, statistical and active learning techniques around this, to um, to to continuously be on top of, like, this scale of debiasing the data. Okay, so this is who we are. Like, this is a very hard and abstract topic, but, we at SkyHive, we're always focused on being the bar and not simply meeting the bar. And, like, as I mentioned, like, by design, we develop ethical AI products. It's in our DNA, and it's in our commitment of as a B corporation that, for profit social good. That's why we've evolved into becoming the global leader in ethical AI and being recognized as the leading startup in the ethical AI field. Um, I will. So this brings to the end of this topic on the ethical AI. Talk many things, went so in some places a little too fast, and there are certain techniques we employ, and I didn't go into details because some of them is our core IP that I didn't want to give away, but more than happy to like answer any questions. I did answer about the medical ethics and others, but any other questions, comments, thoughts, more than happy to answer any questions. There's some questions on how, like, the interpretable AI or all this. Like I said, that it depends on the systems that you're interacting with. Oftentimes, for the regular users, if I go and say, oh, here's my accuracy, and, I have done all the Shapley measures, this is how it's looking. So, the model is robust enough in terms of how it performs. That will be completely lost. Like, I mean, the end user don't know it, like, what the heck is this person talking about, right? So how do you translate that? Right? And so one of the most important things is, like, how do you take all of this and interpret it in the usable language? In our case, right, like, when, say, I've matched you for a job, we show you, what skills you're being matched for, what skills are the gaps, and how do you go fulfill these skills? Now, there could be lineage as well. Like, we can go all the way from like we derive this skill from this experience of yours, or an equivalent of experience that we have seen in in the labor market. So showing that from the UI in those detailed explanations would really help, as to why am I seeing what I'm seeing. There's a question here, what would be the easiest and the best way to judge HR tech services, whether they are compiled with ethical AI? And, that's a great question. It depends, right? If you're really looking at, um, a a uh, a job matching, right? Or go test it very simple. Take a resume, keep everything the same, and the usual suspects, change the demographics around it, and subject it to the system. If it doesn't show similar recommendations or similar skills, then that system is very biased, and it is really skewed, based on certain demographics. It's a very simple test that anyone can just go and perform that. And at SkyHive, we go through this quite a bit. We go through this ringer to our customers. We have done our own audits. We're working with third-party audits, like other partners, in order for us to test through these, both from models, but also from the end products as such. Just one more question: how should HR and organizational leaders interrogate their existing systems, and what kinds of questions should they be asking their vendors as these regulations start to go into effect? Yeah, so, as these regulations, as with any regulation, they're very ambiguous, right? The most common things that you would really see is show us the proof that all of your models are ethical. Then you go back and show your audit results of hey, there's no data bias, there is no algorithmic bias, there is no exclusion, or there's no prejudice, right? So you kind of do. Then the second one is the explanation, right? Even in GDPR, you will say right to explanation, they call it. Why is the machine showing something and how do you explain to it? And so there are right explanations that you will put in. So they have certain clauses associated with each one of them that you would have to adhere to. So the common, because in the absence of a drafted, a law that went into effect, currently it's all up in the air. There's so many questions, what is right and what is wrong. And so, this is that transitionary period. But the most important thing is can I pass the human test, human Turing test, when I'm trying to take something that is similar, but adding some bias in terms of the demographics and I'm testing. That would be and and the questions you should be asking to these vendors is show what have you done at a high level without giving your IP in terms of your practices, the tools and the techniques you've used, without IP, right? And what's your data, what's the data distribution, and what type of data representation that you're using. There's another question, what suggestions could you give to students that face this innovative theme. Uh, Now, I'm trying to interpret if this question is for people, for the students who are learning AI and how they should start thinking about ethical AI. If that is the, like, I'm going to go with that interpretation. Um, yeah, it's very, important that uh, with, with power comes great responsibility. By building all these, powerful AI systems, it's incumbent upon us to making sure that, we have ethical design principles, you know, from the get-go. Because we never know when you put these models into production, there could be harmful effects that that like could cost somebody a job, could cost somebody life. There's so many unintended consequences that we would really see, and it's not right. It's not good, right? So it's being responsible and building responsible systems should be the very first thing in your mind when you're embarking into this new innovative theme. Very cool. Um, I'm going to take a couple of more questions. So I have an anonymous question here. How would you see the future of ethical AI from regulation perspective? For example, China doesn't have this code of conduct and seems to grow faster than the AIs in the US in particular cases. No, eh, yes and no. China does have. They are coming with their own regulatory standards in terms of how it is. Of course, again, it depends on how they interpret what it is. And I haven't personally read the the China's draft. My colleagues have done, but it all in some shape or form, most of these regulations are similar, right? Just like how everyone follows GDPR, most of these regulations in some shape or form are all the same way. It's the main thing here is the enforceability, like how uniform it is. How are these enforced? You know, is there enough guidance around it? That is where it varies. In certain countries, if people don't care, in certain countries, there's high degree of code of conduct. So even though China's growing faster in AI than US, it's my fundamental belief that like you know we humans inherently are fair and good people. It you shake the tree after some time, it all comes to an equilibrium, and you will see the common good all the time. And that way, I'm a big optimist. But I do see there will be a common code of conduct because nobody wants the weapons to start killing people. The AI starts to behave erratically. It's because there's human loss, there's property loss, there's many things, and as humans, it doesn't matter which part of the world you live in. We are inherently we are logical beings, such, and so it's just that there's transitionary time. There are many competing priorities, but they'll all come to an equilibrium. It's a bit philosophical, but I do believe that. One last question. Okay, perfect. I don't see any, but I hope um, you found this useful, and you were able to get to the objectives that I posed, as to the landscape and where things are. And we'll be sharing the slide deck and the video as well. But if anyone else has any other questions, please feel free to reach out to us. More than happy to answer. Thank you very much, and wish you all, happy holidays and a great year ahead.